Right, good afternoon, ladies and gentlemen. So we continue from where we ended last time. Basically speaking, we went up to question 10, right? And that's where we're going to start from. So, question 10. Okay, so we did question 10A and B, right? So I'll go straight to question 11 so that we see if we can do more this time. Right. Okay, so question 11. Solve each of the following equations for the range has been given from 0 to 360, right? So this is the range we're dealing with from 0 to 360. Right, so if you really look at the range which has been given, the first question says 2 sine x plus root of 3, right? So 2 sine x plus root of 3. Okay, so that's the question we have. Okay, so 2 sine x plus root of 3, that's the question that we have at hand. Okay. Okay, so this is equal to 0, alright? Now, before we even go further into these questions, I want to stress to enlighten ourselves on something. Okay, let's first start by writing down the special angles that we know, right? So let's start first by writing down the special angles. So we can say sine theta, cos theta, right? So 0, 30, 45, 60, and 90. Okay, so we start from there, right? So sine 0 is basically 0. Okay, sine 0 is basically 0. Then we have sine 30, which is half. And this is root 2 over 2, which is sine 45. Then we also have sine 60. We also have sine 60. Sine 60 is root 3 over 2. Okay, and sine 90 is 1. Cos, we have cos starts from 1, then root 3 over 2, root 2 over 2, have 1 over 2, then we have 0. Okay, so it's very important that you know this by heart. It's very important that you know those by heart. Okay. Alright, so that is basically what we have at the end of it all. Okay. Right. So 2 sine x plus root of 3 is equals to 0. What we're going to do is we're going to say 2 sine x is equals to negative root of 3 over 2 over 2. Sine x is equals to negative root 3 over 2. right? So basically what we're looking for is x is equals to sine inverse of negative sine root 3 over 2. Okay, so we're going to check, note the sign here is negative. So what is sine inverse of root of 3 root 3 over 2? Now, what you need to also know is that whenever we are dealing with trigonometric equations, what you first find is your alpha, alright? So what you first find is your alpha, then what you're looking for, which is the x value, is the theta. So you can see here, this is theta, okay? So this x is theta, right? So whatever we find here as the inverse is actually alpha, or the terminal side, okay? So if you check what sine inverse of root 3 over 2, so which of these gives us sine which has root 3 over 2 is actually 60, right? So meaning the alpha here which we have is actually 60 degrees, right? Now take note of the sign which you have here. Since it's negative, we're going to ask ourselves in which quadrants is sine negative. So we're going to look for the quadrants in which sine is negative. That is one of the other tasks that we have this afternoon. Right, so we have 4 quadrants basically. We have 4 quadrants. And those quadrants which we have O is positive, sine, tan, and cos is positive in the last quadrant. So if this is the case, which you have 0, 90, okay, so this alpha exists in 2 places, alright? So it exists in the 3rd quadrant and in the 4th quadrant because sine is negative. Because of the negative sign here, we need to find which quadrant is sine negative. So sine is negative in the 3rd and in the 4th quadrant, alright? So in the 3rd quadrant, what is the formula for sine? That's another thing that we need to take note of. So in that quadrant, what is the formula for sine? Alright? So if you check the 3rd quadrant, we said theta can be found as 180 plus alpha. Alright? So this is how we find theta, 180 plus alpha. So we have alpha 60. So theta is basically 180 plus 60. Alright? So we have 180 plus 60, which is 240 degrees. So that's the first one. Okay, so that's the first answer, 240 degrees. The next one which we have, alright, we have theta. We have theta in the 4th quadrant, which is 360 minus alpha. So we have theta is 360 minus 60. So theta is equals to 300 degrees. Right? Therefore, x is equals to 240 and x is 300. Here we can also, these are the values that you are looking for, 240 degrees and the 200 degrees. Okay, that's how we go about these things. Alright, now, some of you may be looking at this and it looks Chinese. How did they derive that? Okay, so how do they derive that? Special angles are never given in the exam, so you have to know how to derive them. Okay, so if you are looking for, you first consider this triangle with 3 equal sides. Okay, so we have 2 here, but it's going to be cut in half. So this is 1 plus 1 is still 2. All right, so we consider this triangle with 3 equal sides. Alright, so this is 90, this is 90. Now the sum of all sides in the triangle should equal to 360. So we actually have here, we have 60 there, we have 60 here, and we have 30 here and 30 here, right? Because this is being cut in half, alright? By the Pythagorean theorem, we can find this side because we know this side, we know the hypotenuse, we know the adjacent, so we can say hypotenuse squared is equals to adjacent squared plus opposite squared, right? So assuming that the side I'm talking about is the one with the 60, so we want to know what this side, which is the opposite side, is. If you regard this as the 30 degrees, you're still going to consider this side as the adjacent side. Okay, so what we now have is the hypotenuse is 2, so we have 2 squared is equals to adjacent, in this case is 1 squared plus opposite squared, right? So this is the side I'm looking for, or you would have said adjacent. Okay, so this is 4, 1 plus opposite squared. So we have opposite squared is equals to 3. Alright, so take the root on both sides, the opposite is therefore equals to root 3. Right, so this is root 3. Alright, so that ends up becoming root of 3. Okay, so now that we know that, we can easily find 30 sine 30 cos 30, and we can also find the other side. Okay, then we'll talk about the one for 45. Okay, so right, so now that we have that side, right, so always remember that we have such a triangle with 3 equal sides, and one of them is 1, 1, and we cut it in half. Right, so if I'm looking for sine 30, let's say sine 30 degrees, we know that sine 30 is opposite over hypotenuse. So opposite over hypotenuse, in this case the opposite is 1 and the hypotenuse is 2. So this is why sine 30 is actually half. If you're looking for sine 60, 60 is still opposite over hypotenuse, and if you check, the opposite now is root of 3, and the hypotenuse is still 2, so you have root 3 over 2. So this is how it gets to those two, root 3 over 2, and you also have 30 as half. Alright, so if you are going to talk about now the one which we have for 45 degrees, right? So for the 45 degrees one, we actually consider this sort of a triangle. Okay, and we have side 45 degrees, then we have root 2, and we have 1, 1. Okay, so this is for the 45 one. Of course, you can see that the hypotenuse is root of 2 because you have the adjacent and the opposite are both 1. Okay, so if you really drew this accurately, you'd notice that this one and this one are supposed to be equal. Okay, so this is supposed to be equal. I'm just saying this because trigonometry, the special angles will not be given to you, you have to derive them on your own. So in an event that you've not mastered them, this is how you can derive them. This is what we are talking about so that you can easily use them. Okay, so this has already been taught, but I'm just doing a recap on it, being a tutorial. Okay, so one, of course, 2 sides, 1, 1 with that. So if you are looking for, let's say, sine 45. Okay, so sine 45, we know it's opposite over hypotenuse, so opposite is 1, okay, over, then you know that the hypotenuse is root 2. If you are going to rationalize this, you are going to have the final answer as root 2 over 2. Okay, so that is what you are going to have. So this is where we get the root 2 over 2 from. Okay, so let's continue from there. Okay, so if you are looking for cos, it's the same thing. So we have cos of 30. Cos is adjacent over hypotenuse. So if you look at 30, adjacent in this case is 1. Alright, so the adjacent side for this one is root of 3, and the hypotenuse side, so root of 3 over hypotenuse, which is 2. Okay, and we know that cos of 45 degrees is still adjacent over hypotenuse, but now referring to this one here, you have the adjacent being 1 and the hypotenuse being root 2, so that's 1 over root 2, which ends up being root 2 over 2, so multiplied by root 2 over root 2, so this is root 2 over 2, okay, once you rationalize that. Alright, so that's how you go about such questions. Now, let's continue. Okay, so let's continue. Alright, so let's continue with question 12. Let's continue with question 11. Okay, so I have a question which says tan squared x is equal to 3. Tan squared x is equal to 3. Alright, so what you need to know here is this tan x squared can be written as tan x then squared then x equals to 3. So take the root there, so you have tan x is equal to plus or minus root of 3. Right, so whenever you solve a quadratic equation, you expect to have 4 solutions. Okay, so expect to have 4 solutions. As I said before, what you have here is not your alpha, what you have is your theta. Alright, so that's that. Okay, so x is therefore equal to tan inverse of root 3 and x is equal to tan inverse of negative root 3. Okay, so basically those are the 2 solutions that we are going to have. Okay, so the first thing that we're going to ask ourselves is what is tan inverse of root of 3? So what's alpha gives us root 3? Okay, now if you look at what we have there, okay, we know that tan of 60 is what is going to give us root 3, right? So tan 60 is actually root 3. So we're saying tan inverse of root 3 is actually equals to 60 degrees, okay? But we're saying alpha is what is giving us as 60 degrees. So that is what we have there. Alright, so now that we know that alpha is 60 degrees, what we are going to say now is root 3 is positive, so in which quadrants is actually tan positive? So tan is positive in the first quadrant, and also tan is positive in the third quadrant, alright? So in the first quadrant, we know that alpha is equal to theta, okay? So that's in the first quadrant. Alpha is equal to theta. That's in the first quadrant. Then we know that if alpha is equal to theta in first, this is first quadrant, then we know that theta is actually equal to 60 degrees, right? Then we also know that we have the third quadrant where theta is actually positive, right? So we know that tan is positive in the third quadrant, but the formula in the third quadrant is given as theta can be found as 180 plus alpha, right? So theta is equal to 180 plus 60 degrees, which is actually 240 degrees, right? So we're saying tan inverse of root of 3 is actually 60 degrees, okay? So now that we know what we are dealing with, the next part we're going to do is we're going to now look for the closest that we have, right? The next one which we found was the tan inverse was tan inverse of negative root 3, okay? Which is actually negative tan inverse of root 3, right? So we know that this again alpha is what? 60 degrees. But ladies and gentlemen, we know that tan is actually negative here, right? So in which quadrants is tan negative? So tan is negative in the second quadrant and in the fourth quadrant. So tan is negative in the second and in the fourth. So in the second quadrant, okay, so in the second quadrant we have tan, which is theta is let's see. Okay, let's erase this. So we've already found theta. Theta was 60 and theta was 240. Okay, now I'm saying for tan inverse of negative root 3, okay, negative tan inverse of 3, this is still 60 degrees, but we're looking for quadrants in which tan is negative. So tan is negative in the second quadrant, and in the second quadrant we know that theta is found as 180 minus alpha. So theta is equal to 180 minus 60, okay, which is 120 degrees, right? Then it's also negative in the fourth quadrant, okay? In the fourth quadrant, the formula is given as theta is 360 minus alpha, right? So theta is equal to 360 minus, in this case, 60 degrees. So we have theta is equal to 300 degrees, right? So this is basically the two answers that we have for theta. So now that we know what theta is in those quadrants, x is therefore equals to 60, okay? We have 120, we have 240, and we have 300 degrees. So this is the answer for x for that particular equation, right? So this is how you go about such questions under trigonometry. Okay. Alright, let's go to the next question. Alright, so next up, C. We're now doing C. C says 2 cos squared x is equals to cos x. Right? Now, ladies and gentlemen, one of the mistakes that students make most of the cases when dealing with such questions is they have a tendency of dividing both sides by cos x. Alright? Doing that, you lose out the value. Okay, so whenever you are faced with such questions, do not divide both sides by cos x. I know it looks tempting, right? But do not divide both sides by cos x, right? So what do? You actually collect like terms. This goes to 0. Right? After you do that, then you say what's common is cos x. What remains is 2 cos x minus 1. This is equals to 0. This is what you get. Okay, so let's continue. So as I was saying, you have these 2 cos squared x is equals to cos x, alright? So this is C, right? Now we're saying that it is very tempting for you to divide both sides by cos x. As you can see, it looks common, huh? So that you remain with a 1 here, then you have 2 cos x is equals to 1. But in doing that, you lose a value, okay? So you end up getting it wrong. Even if it's, you're dealing with maybe something which is not a trigonometric function, but maybe a quadratic equation or some other polynomial, do not be tempted to divide both sides. Usually just collect like them. So this cos x here has come the other side, all right? And we have now a subtraction there, which is taking place. Okay, so from there, what we now get is, I looked for what was common between these two guys. So what was common was actually cos x. So factoring out cos x, we have cos x, 2 cos x minus 1. So the first one is that cos x is equals to 0, right? Or the other one, 2 cos x minus 1 is equals to 0. So you have 2 cos x is equals to 1 over 2 over 2. So cos x is equals to 1 over 2, right? So that is what you get. Cos x is equals to 1 over 2, right? Okay, so cos x is equals to 1 over 2. Then how do we proceed from there? So now here we need to find x. So x is equals to cos inverse of 0, right? So x is cos inverse of 0. So we need to know when do we have alpha being equals to 0, or when do we have this cos inverse of 0. So we know that cos is actually 0 at 90, right? So you can see here, from here, that cos is 0 at 90. So meaning that since the range which you've been given is 0 to 360, it's 0 at 90 and it's also 0 at 270. So the two values that you have from here is that alpha, right, will be 90 degrees and alpha will actually be 270 degrees. Okay, so which is actually, yeah, so this is what you have. So alpha is 90 and alpha is actually 270 degrees. Or basically speaking, we know that cos of 0, okay, so 0 is actually a digit number. We know that cos is 0 at 90, so this is why you have your alpha as 90. Alright, so if you subtract 270 minus 90, I mean 360 minus 270, you get back to 90. If you subtract 90 from 360, you still get back to 270. Alright, so this is basically what you are going to have. Okay, so anyway, let's get back to that. Okay, so now 90, if you look at 90, this is basically your alpha, all right? So this is not the theta that we're looking for. So what is theta at 90 and what is alpha at 270? So this is where we are going to get to. Okay. Now, if you look at where 90 is, okay, so if you look at where 90 is, we have theta. Here, theta is going to be 90. So we say 180 minus 90 to 90. Okay. Then the other theta was going to be 360 minus 270, okay, which is still giving us the same answer as 90 degrees, right? So basically speaking, if you consider what cos inverse of 0 is, you notice that the answer gets back to 90 on both sides, alright? So that's the first value we should have. Now, what is the value when we have cos being equals to cos x being equals to half? When cos x is half, okay, so we have cos x is equals to 1 over 2. So x is equals to cos inverse of 1 over 2. Alright? So now cos of 1 over 2, if you look at there, you get back to 60. Right? Of course, not always that it will give you 60, it's just that the examples that we've done so far are both taken back to give us 60. Right? So basically speaking, okay, so if we say this, which we have okay, so if what we have here is half, which is 60 degrees, the question is in which quadrants is cos positive, alright? So this is positive, so cos is positive in the first quadrant, and cos is also positive in the fourth quadrant, right? So in the first quadrant, we know that alpha is equals to theta. So since alpha is 60 degrees, then theta is also 60. Then in the fourth quadrant, in the fourth, we know that theta is equals to 360 minus alpha. Right, so theta is equals to 360 minus 60. Theta is actually equals to 300 degrees, right? So that is the answer that we have for that particular question. That's basically how you go about these things. Okay, so let's look at the different sort of questions. So the answers that we have in this case, we have 300, we have 90, we have 60 degrees. Okay, so those are the three values which we get. Okay, so sometimes you can actually have, you know that cos x is equals to 1 over 2. So which one gives you 60 degrees? So cos of x is equals to 60, so this is what you have. And the answer you have is the alpha, as we say. So that is alpha, then what you do is you find the inverse, okay? So since you have alpha, you're now looking for theta, right? So when you find the inverse, that is actually alpha, or the terminal point, okay? So it's the terminal side, or the special angle, it's the terminal side, then you are going to find theta using the particular formula in the quadrant that is given. Okay, so that's how you solve such a question. Let's go to the next question. Okay, so basically the answers from the previous question are 0, 1, Okay, so that's what we get as the answers. Okay. All right. Next up, right, so we have question 12. Question 12. It says solve the following equations. Okay, maybe let's consider a complicated one, such as 11e. Okay, so similar 12. I'll start with 12b, or we can start from 12a. Right, so it says 2 tan theta sec theta minus tan theta is equal to 0. Okay. If you look at this question, what is common here is tan theta, so I can actually factor out tan theta. Then what will remain is we have 2 sec theta minus 1 is equal to 0. Okay, so we have tan theta is equal to 0, or 2 sec theta minus 1 is equal to 0. Okay, so theta here is found as tan inverse of 0. Okay, now if you look at tan inverse of 0, the only place where we have the tan inverse of 0 is actually at 0. Because remember that tan is sine over cos, so sine 0 over 1 is actually 0. So that's just at 0. Okay, so this is 0. Okay, so 0 degrees, that's the answer which you'll have there. Then apart from that, now we can actually check, it doesn't end here. We also want to know in which quadrants are those negative. So we want to know in which quadrants are those, is tan positive, right? So in which quadrant is tan positive? So tan is positive in the first quadrant and also in the third quadrant, right? So meaning that if you consider the first quadrant, you know theta is equal to alpha. So in the first quadrant, theta is equal to alpha. So we have 0 degrees as theta, all right? Then we also, since it's positive, where else is tan positive? So tan is positive in the third quadrant. Okay, so yes, it's tan is positive in the third quadrant. So there we have 180. Okay, so we have 180 plus theta. So this is simply 180. Okay, so because theta is found as 180 plus alpha, right? So theta is given as 180 plus 0 degrees, so this is actually 180 degrees. Okay, so you actually do a similar thing with what we did last time. Remember, we're dealing with cos theta is equal to 0, so we're looking for theta being equal to cos inverse of 0. Now we know that cos is actually 0 at 90, so this is actually 90 degrees. So we're supposed to find out in which quadrants is this one positive. It's positive. So since it's positive, cos is positive in the first quadrant, right? In the first quadrant, and also in the third quadrant, in the fourth quadrant, right? So in the fourth quadrant we have 360. Okay, in the fourth quadrant we have 360. Right here. I'm referring back to the previous question which we did. Remember we had 0 and we have another 0 here, so this is why I'm dealing with both questions in a similar manner. So we're saying that for the previous question which we had, remember we had a component which had cos theta is equals to 0, right? So cos inverse of 0 is 90 degrees. So now in which quadrant is cos positive? It's positive in the first quadrant and it's also positive in the third quadrant. So in the first quadrant, we know that theta is equal to alpha, so we have 90 degrees there. Alright, then in the fourth quadrant, we have theta is actually equal to 360 minus alpha. This is why you have 360 minus 90 degrees. So the other one was actually 270 degrees. So this is where the 270 was coming from. So that's why we had the values being equal to 60 degrees, we have 90 degrees, we had 270 degrees, and we had 300 degrees. Okay, so these were the answers to the previous question which we had. So this is the answers which you need to get to. All right, so apart from that, now we're dealing with a new question. This is question 12. So question 12, we're saying tan theta is tan theta. I factored out tan theta. This is how we got to that. So we have tan theta is equal to 0. But where is tan 0? Tan theta is 0. I mean tan is 0 at 0. Okay, so at 0, because we know tan is sine over cos. Okay, so sine is 0 and cos is 1. So 0 over 1 is 0. Alright, so that's how they got to this 0. Now, we want to find out in which quadrants is tan positive. Alright, so tan is positive in the first quadrant, it's also positive in the third quadrant. So in the first quadrant, we have alpha is equal to theta, so this is why you see that I just wrote 0 there, right? So then in the third quadrant, you know that theta is given as 180 plus alpha. So we have theta is equal to 180 plus 0 degrees, which is 180. So that is the first set of solutions which we have. Right, now we need the second set of solutions. We need to find the second set of solutions. So in the second set of solutions, we've been told that we have 2 sec theta minus 1 is equal to 0, right? So we have 2 sec theta is equal to 1 over 2. We divide both sides by that. So we're looking for sec theta being equal to 1 over 2. Alright, now I know that some of you may not know what sec theta is equal to 1 over 2 is, but what you need to simply know is this is the same as you're looking, theta is sec inverse of 1 over 2. Alright, now you know what sec is. Sec is actually 1 over cos. So this is the same as saying you're looking for, this is the same as saying you're looking for, we can say 1 over cos, okay, 1 over cos inverse of 1 over 2, right? So this is the same as 1 over cos inverse of 1 over 2. So where is cos, so we're looking for 1 over cos, right, inverse of 1 over 2, right? So this is basically what we're looking for, 1 over cos inverse of 1 over 2. Now we know cos is actually 1 over 2 at 60 degrees, right? So this is basically the same as 60 degrees, right? So we are looking for cos of 60. So we're looking for cos of 60. And what is cos of 60? Then we can easily relate to what we have, alright? So, cos 60, that's the alpha. So in which quadrant is cos positive? Because wherever cos is positive, that's where sec is also positive, alright? So wherever cos is positive, that's where sec is also positive, alright? So now, in that case, what we are going to have is we know that this alpha is now 60 degrees, right? So alpha is 60 degrees. Now, if alpha is 60 degrees, where cos is positive, that's where sec is also positive. Where cos is positive, that's where sec is positive, that's where also cos is positive. So it's positive in the first quadrant and it's also positive in the fourth quadrant. So meaning in the first quadrant alpha is cos to theta. So meaning now theta is at 60 degrees, right? Then in the other quadrant which we have, in the other quadrant we have the fourth quadrant, right? In the fourth quadrant, what we get is we have theta being equals to 360 minus alpha, so we have 360 minus 60 degrees, which is actually 300 degrees, right? So this is what we have as our theta. Our theta is 360. Therefore, theta is equals to 0, 60, we have 180, and finally we have 300. Okay, so that's basically the value of theta which you get if you happen to solve that, right? Zero, 60, 180. Okay, so that's how you sort out such questions. Okay, so question 13. Unfortunately, due to time, we'll not get to any question, right? So this marks the end of this tutorial today. Have a good day.